2, 3. Perfect. I can hear myself. Can you hear me? Okay, I know you can hear me because I heard myself on YouTube, so perfect. Now we can actually start today's episode, and today I will talk about... So, last time I said I might talk today about the PJL task from... what's it called? From Insomniac, but in the end my exploit didn't really work and I didn't have time to finish it, so I decided to do something easier today. Instead. And easier, by easier I mean maybe not super easy, but last weekend, like actually last Sunday, our team, Dragon Sector, ran the Confidence, DS, CTF, the teaser, which is ranked on CTF time, and it was run for 24 hours. There were, I don't know, like 8 tasks or something like that, or 7 maybe. And I did make one task there, I did solve another one, so I decided to show it. How do you solve them? One of them will be like really easy, like almost everyone solved it, so... But I know also new people new to CTF scene are watching my streams, so I decided to show it anyway. And then I want to show you a forensics tasks, which is like forensics 400, it was called index. That's the second task I'm going to show. And if there's still time, I'm going to show you Derailed, which was a Ruby web challenge, which was not really solved by a lot of people, so that might be more interesting, and I hope we actually have time so I can show you that. The Ruby one is a little tricky, so it's like this. The first challenge I'm going to show you, which is starblind, is like, I made it. I know it. Like, I know everything about it. Well, maybe not everything, you know. I don't know the things which I did wrong, but I know the things which I did right, and so I know how to solve it. The second one, I did tests, which means I did solve, so I know how to solve index as well. That being said, I didn't solve derailed, I just looked at the test exploit we had for it, you know, to test it during the CTF. So that might be funny, because I might end up having problems solving it on the stream, so we'll see how it goes. Okay, today's moderator is KrzaQ, as usual. So if you have any questions, just ping him on IRC or ping him on YouTube chat, and he will let me know using telepathy or maybe our voice chat, one of the two, depending on which one is more handy at the moment. Apart from that, let's do some usual news. There aren't too many news. So this is KrzaQ's blog if you're interested. If you actually speak Polish, then like replace the dev here with DSP. And there are quite a lot of more recent blog posts. Then Live Overflow, as always, if you are into CTF and you don't know this channel, you probably should subscribe. Or even if you're into security and you're not into CTF, that's still like a great channel to subscribe. So Live Overflow. And Project Zero from Google actually released, so Gal actually released a really cool blog post on exploiting Broadcom's Wi-Fi stack. I'm going to spam the link on both chats. Well, not really spam. I'm going to copy paste it though. So it's a pretty long and good read on how does the modern Wi-Fi work on... Yeah, and basically how do you exploit them. That's pretty awesome stuff, so I totally encourage you to read it. Apart from that, if you're following the recent events on the CTF scene, there seems to be some some drama going on between ICTF and between CTF time and between LCBC. So if you basically just look up venue on Twitter, if you look up CTF time, there are links to some interesting blog posts and overviews. So TLDR, LCBC was banned for the DDoS, a rather interesting DDoS on the ICTF, and like there's a forensics analysis of it and some other interesting drama going on. So if you're into like dramas, then it's an interesting read, and there's some cool technical aspects of this as well, and interesting like it's interesting also how people pull different rules from different places into the play. But we're not going to talk about that. We're going to talk about Confidence CTF. So Confidence, if you don't know, is actually a conference, like a security conference in Poland, in KrzaQ. It's been going on for, I don't know, ages, like 10 years maybe more. it's like, I really like the conference. What can I tell you? I've been going there like both as an when I wasn't even a speaker yet, just like somebody who just got into the security scene. Then I also did some talks there. I won some CTFs there, and now our team is actually doing the CTFs. So yeah, it's a pretty cool conference in KrzaQ. So we usually do like one CTF, one teaser CTF online with them with about 8 tasks, and then we do another online open for conference attendees. That's the important part. Offline CTF in KrzaQ during the conference itself, and you can actually win a couple of $1,000, like I think around. So these are the prizes on the on-site, and this is around like $2,500, I believe. So that's pretty okay for a CTF. It's nothing close to, you know, the Korean CTFs where you can win like 50 grand or something, but it's something. Okay, so let's start with the task I did, and it was called starblind. So starblind looks like this. I actually like making my tasks look a little more interesting graphically. One thing I'm actually proud of is the way it resizes. It like tries to keep the background from resizing, but it still keeps the ratio by, well, extending the background if it's required. So yeah. Anyway, so, well, there is some story here, and the story is about you just arrived in this star system, and it seems that it's occupied, like there are people / robots / aliens, whatever, having mining facilities and other stuff here. And the question is like, who does this star system belong to? Because it's obviously maybe not humans, maybe humans, who knows? And actually you have to type your answer here. And well, if I type just something like this, it says nope, sorry. So yeah. I'm going to do a spoiler alert. Do you know what took most of my time coding this? It wasn't actually this effect, it wasn't the CrzaQ itself, it was actually the plasma on the sun. I don't even know if you can see it because it's so like a subtle effect, I would say. So, but yeah, that took most of my time. Yeah, because yeah, that's how it works, I guess. So let's see how we can actually, how do we crack it? Let's start maybe with opening this, or actually not. Let's do Control U, which Control U brings us the source code. Okay, so there's a question. While this loads, it might load for a second. There's a question from Christian. What about my books? Any news? Actually, the translators gave me the full translated first book, which is To Understand Programming. It's translated to English, but there's still like editing to do. Actually formatting, then editing, and then actually applying the changes to, because I want to publish the second edition, and the second edition wasn't even written yet. So yeah, basically like end of 2018 is what I'm planning for to publish my first book. And the second book, I don't have good news so far. Like the publisher isn't at this point interested in actually publishing the book in English, but that might change, so we'll see. The second one is on reverse engineering, by the way. It's written by several authors. So what happened? I actually wanted to open this in a new tab, but it closed because, as you can see, it's actually a script, right? One huge script which is as like inlined using base64 as a pseudo file in the data protocol, and there is actually, I think, nothing else here. Like that's it, right? It's like script at the end, and then like HTML closing tag here, and so we need to decode this. It's obviously like, I wouldn't call it obfuscation, let's call it maybe obfuscation, but it's not really obfuscation. It's more of a way to make the CrzaQ fit into one HTML file and not have any dependencies on external files. Okay, I'm going to try to open it again in a new window. So I clicked again, Control and left click on this text, and you see it opens the tab and it closes it. That's annoying. I'm going to download it in that case. So let's do this, and I actually had a... Okay, I don't know. I think I'm going to solve it under Linux. I'm going to spawn a Linux console. Here it is. Now let's download it. wget and this. And yes, it did download it. And as you can see, or maybe you cannot see it, it's 1.4 megabyte. And I guess the first thing we would like to do is we would like to get into that base64 stuff. So just to keep this file opened, it looks like this. Okay, I'm just going to maybe press it once. What I'm going to do is I'm going to split for this and split on the ending tag, like load it into Python, right, obviously. So to load it into Python, I do open starblind.html, read binary, or read binary, that's not really necessary, I guess, especially under Linux, so just read. Now I'm going to split it on this thing. So it treats this like a delimiter, and this part, everything before it will be treated as like index 0 in the returned list, and everything after it, so after the comma, will be actually index 1, so I'm going to do just this, and I'm going to assign it to D again. What did I mess up? Oh, there's actually a quote here, so a double quote, so I need to use quotes instead. Perfect, now I'm going to basically cut off this part, so I'm going to again split it by this part, because I know this string that isn't going to appear in base64, so I'm just going to like split it, and this time I'm taking the 0th element, which means like everything before it, right? And now I'm going to write it, no, I'm going to decode it, I'm going to write it at the same time to some file, so let's call it, I know it's JavaScript because it's in the script tag, right? So open starblind.js for writing, write decode and base64. If you're new to security, you probably should know that base64 isn't an encryption scheme, it's an encoding scheme. The difference is that the latter isn't, you don't do it for security reasons, you just do it to have the data in some form and not in another form. In this case, base64 actually allows you to store the whatever content in text, like ASCII, safe printable characters only content, so even if you have binary data, you still get it. So what do we get after decoding it? This is the file open, like sb.js, as you can see, and we get some asset image, and it puts, so this is some image. I mean, we can plainly see that there are some images here, right? I mean, images all around, everywhere. So I'm going to ignore the assets, I'm just going to press page down, then we have some plasma, and then we have calc SHA4. SHA4, as we know, doesn't exist. I mean, SHA3 just basically was standardized. I don't know if it even was standardized already, but yeah, so this is bogus. But I'll keep scrolling. So yeah, there's some crypto here. I'm going to look at it later. Let's just scroll to the end of it. Yeah, quite a lot of it. I'm just going to hold page down for a while, I guess. No, I'm going to use the scroll bar, it's too much of it. Vim isn't too happy about this sudden jump, I guess. Yeah, come on, Vim. Yeah, perfect. And I get to some... Oh, we have the text which is scrolling, so we can actually read it. You can read the story. And there are some... Yeah, again, as I said, this was made by me. The sprites and font are common creative, and there are some greets to other CTF teams, because why not? They are really awesome. So basically this is where the, I guess, where the SHA4 function ends. So I'm going to ignore it for now. Then there are some global variables. And oh, this is interesting. We have like some passwords, some last checked, whatever, and good password, it equals false. So what happens if I set like this global variable to true? Blah 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 equals true. And great work. Okay, but this doesn't give us the flag, so that's not the way to go around it. So let's see, like image to data, whatever. Handle, this is probably being called when it's actually loaded, like handle on load, right? And some canvases are created, initial scene, whatever, and key down. Key down is probably something interesting, because this is what happens when we type stuff, and this is what is interesting for us, because, you know, we have to type in the password, which means it will be somehow connected to checking the password. And this is this function, so we can actually analyze it. And yeah, as you can see, it's actually adding the characters into the gpassword string, and there have to be 27 characters, it seems. So this is, we could count them, of course, in the UI, but whatever, we know now it's 27. And then it does password checking using check password. So, excuse me, let's look for this function. I'm just going to do this. Okay, perfect. So if password length isn't 27, then good password isn't a good password. Then calculate the hash of the password, and the hash has to be this. So this is the hash which we want to get. I guess that's the idea. And I'm going to probably do it in Python, because why not? Yeah, so this is the correct hash, and we need to somehow, I don't know, brute force it or something. It looks somewhat random-ish. I mean, this is a little repetitive, but apart from that, it looks pretty random. Though not a lot of the high bits are set, for example, in this area, right? Like only here the high bit is actually set for A. So this is quite interesting. Apart from that, no, it looks like we're like odd numbers, even numbers, I mean even numbers and odd numbers. So that's okay-ish. This area looks totally more entropy heavy, I would say. There are the highest bits set for way more of them. So actually, no, actually here the highest bit is set as well, right, for 8. Yeah, but I don't know. I mean, we have to analyze the function. I wouldn't know how to solve it just by looking on the hash, and that was basically the idea. So I'm going to scroll back to. I'm actually not going to do it in Vim. I guess I'm going to just open the lister, because the lister, while it doesn't have, while it isn't, you know, coloring the syntax, it actually doesn't have problems with huge files. So it might be a little better, because Vim isn't happy about these long arrays at the bottom. So let's see what's this calc SHA4 is doing. Not using Vim 8, so not on this, yeah, not on this PC. I need to reinstall it. I have the new one on my laptop. I did some minor improvements there, which made me want to switch to it, but I didn't do it yet. Anyway, okay, so it takes the block, right? And the block in our case is the password. Let me maybe zoom it. Then it creates a 64-byte array. It's actually cool that now JavaScript, like the modern JavaScript, is typed basically since you can do this. And then it actually copies the letters of each. Yeah, the letters of each. Each letter of the password it copies to the nth index in R being this, let's go to just register, because that was the idea. And it goes up to block length, and block length is, I guess, well, 27 for us, and then starting from 32, it actually does this being probably some form of initialization. So it basically, I guess, the hash is, the initial registers are initialized like this, but the password goes to part of it, right? So this is where the password goes. Then this area is actually zeroed. I mean, it's not initialized, right? Because this stops at 27, but when we start at 32, so this is like not initialized, these are just zeros. And then the pseudo-random numbers go here. So this is how we start, and this is our initial stuff. Syntax clear in Vim speeds up Vim. That's true. I think you can also like, yeah, exactly. Adrian says it on IRC that you can do set syn max call, which means don't apply syntax after these many characters, like for example 120. So these are good tips. I'm still going to stick with because I already have it on. Going further, it actually declares two functions, like two, how do you call them? Nested functions. That was the word I was looking for. One is XOR or XOR, whatever you like to call it, and it does what it says. It probably takes an array, right? And then it XORs each register with each of well, not really each. It XORs nth index in the registers with nth argument, where im is actually a list or an array or whatever you want to call it. And then we have perm, which probably stands for permutate. Can you see it? Yeah, you can see it clearly. So what does it do? It, again, im seems to be a list because it's like used as a list, right? And what happens here? First I is which goes from 0 to 512, it's being translated into bits and bytes. So yeah, that's pretty normal. So like, I don't know, if you have like 12, right, that means that is the first byte and the fourth bit. And well, of course, counting from 0, so that would be like actually second byte and fifth bit, but yeah, well, that doesn't matter. This funny syntax, like with or 0, is in JavaScript, so this is like a pipe. In JavaScript, that's actually the same as doing an integer division, which means get rid of whatever you have after the dot. So bring it to the, not really nearest, bring it to the integer, like which is closest to 0, I guess, in this case. And then sign is run, like math sign or signum, whatever, on this. And if the sign is there, which means it's like -5, for example, right? Then it gets rid of the sign here, or so this is basically like an absolute value, which is fine. Then the source bit is the index. The index being the index being this is being again translated into the byte and the bit using the exact same math as was done here. Yeah, it's basically int casting. That's what I wanted to say. Like this part is int casting. Thank you, KrzaQ. And then from the register, from the source registers, from the source byte, the source bit is taken. This is basically like a, you know, boilerplate code for grabbing a bit from a desired location, like a desired bit. It's put in B. If the sign was there, if the sign was present, then this does XOR with 1. XOR with 1, if you have one bit only and you XOR it with 1, that basically means like do a bit complement. So 0 changes to 1 and 1 changes to 0, like that. Or like, you probably might know this like as a negating a bit. And then this is like, and being probably the destination array, yeah, because like R is replaced later on. It's basically the same as this, but the other way around. This means put the bit B on the desired position being bit destination bit inside the byte destination byte of n. So it's, yeah, it basically what I guess it boils down to, right? If you have, let's say, like 5 bits, like A, B, C, D, E, it basically like reshuffles them. It's just like a shuffling. For example, B might end up here, then I don't know, A might end up here, D might end up here, depending on the input, right? C and I guess E, like it does reshuffling, but it also might do, because of this, it might do bit complement, meaning that this might not be B, it might be like negative B or negative D, depending on the sign. So we have, we now know that we have then a series of this stuff, right? We have an XOR, permutate, XOR, permutate, XOR, permutate, or actually shuffle would be a better name, with some parameters. In case of perm, some parameters are, well, with sign as expected. So yeah, so that looks quite easy. It actually looks easy from two perspectives, I guess. First, because shuffling in this case can be So there's actually a good question. Is it really shuffling, or are these like all the numbers from 0 to 511, or not all the numbers, meaning some number repeat? Because if some number repeat, then that means that, for example, if we had like, again, let's go with ABC, then if you, in the input, if you repeat, for example, 0 3 times, then you get actually, you know, actually A, which makes things even easier actually. Then so I'm going to go with that. But you can, I guess you can reverse it. XOR with constant values, you can also reverse it. So that looks fine. Let's see what happens at the end actually of all this. Oh, I think I went too far. At the end, we create a string named hexdigest. I guess based on the name, you know where this is going, right? It takes each register, it converts it into hex. Yeah, so each register being 8 bytes. 8 bits, obviously. And if the length of the converted letter is not lower than 2, then like add 0. It means like if you get like A, for example, then add a 0 at the beginning and then add it to the hex digits, which means it actually, you know, just outputs the final hash in text form, in hexadecimal encoded form, actually. So, what do we do? Well, what we can do is we can, since XORs, the weak part here seems to be that you can probably reverse it, and if you cannot reverse it, you can brute force it, and you can probably brute force it bit by bit, because it doesn't seem to be doing XORs with like one register with another register, which is normally done inside like MD5, SHA, and so on. It's not done here, which means you can probably just brute force it bit by bit, because like the permutation is bit based, and XOR like by definition is basically bit based. So I'm going to copy paste it into Python, and then I'm going to re-implement it in Python. You know what? I'm actually not going, or am I going to keep it? Yeah, let's keep it here. Set syn max call. Again, Adrian, thank you for this. Let's do this. And this should, I guess it should work rather quick. As you can see, like the syntax coloring really like stops here, right around 120 column. So we have these functions, but I do need to implement them. I do need, I guess, to initialize them in the same way, and then I'm going to brute force it bit by bit. So I basically need to implement it. I'm going to use Python because why not? And well, yeah. So r equals byte array. Yeah, r is okay. Byte array 64. I think in Python it should give me exactly the same thing. Yeah, and now I can like just do. Yeah, perfect. It works perfectly. So that's exactly what I want. Now it actually initializes it by. I probably should like copy this everything. So from 12 to the end, put at the beginning 2 spaces, and I'm going to copy. What happened? Please redo. Why didn't I type 12? I did type 12. I didn't put the space at the. I don't know. Whatever. Let's call it calc, because why not? And let's put password here. Okay, and well, the first thing I'm going to do after I implement everything, right, I'm going to actually run it with whatever I type. I'm in JavaScript. I want to check if the same result I get in Python, because that's the best way to check it, right? And then I'm going to actually do bit by bit brute force. So I do need to first of all, for ch like character and password, or actually like let's make my life easier, just put it. I think I can do it in a different way. I think I can just write then password equals byte array password. This should work as well. If it doesn't work, I'm going to go for a 4. So that's it. Now I need to do this. So I guess like I in range 30 to 64. I have no idea what I'm doing. I don't know what I'm doing. No, seriously. Which part do you not understand? That's the, I guess that's the big question here. But what I'm doing, I'm typing, translating this to Python because Python is my language of choice, and then I'm going to do a bit-by-bit brute force. I guess you'll see on the way. Now I need to create 2 nested functions. Thankfully, I guess they'll work the same way in... I think I don't want to go with nested global. Yeah, I won't go with nested. I'll go with not nested functions. XOR. Yeah, looking at one language and typing in the other, perfect. And typing in it, no, never mind. So, for I in range. No, that doesn't make sense. Whatever, that's not Python. Yeah, that's Python. I need to copy this though. Okay, why did it break my coloring? Oh, because probably of the hash. I'm going to put the hash here so it doesn't break my coloring. And now that is equal to I multiplied by this funny... No, well, no, that's done here. So I was typing XOR. Yeah, I am. Perfect. And now I need to do the permutations. I shouldn't copy it, probably, or should I? Let's copy it. Maybe we can reuse some of the code. Again, the registers is something I'm going to... Can I download this HTML file from somewhere? Yeah, sure. I'll just give you a link. But basically, if you go to like CTF dragonsector.pl, you can still download it from there. And it's also, I believe, on my blog. Like if you go to genveil.pl/starblind.html. Yeah, it's here as well. I'm going to publish the source code of it later on. I mean, not today, but like in a few days. Cool. Now, n equals byte array 64. Basically translating it to just a different language. Because I can reuse most of it. Okay, now I don't need the semicolon. I don't need this because Python's division is already integer. I don't need this signum function though. Let's just like type signum turn v smaller than 0 and okay, this is SGM, obviously. So it will be either true or false. Now Python, I don't believe Python has like a syntax notation like this, but what I can do is I can do create a dictionary with this kind of stuff. If it's true, then this. If it's false, then this. This should be fine in Python, though I need to do same. Yeah. Okay, again, this is the same thing. I do not need this because this doesn't change anything in Python. This is a valid Python expression. This isn't though, so let's do this. XOR works in Python the same way, and this is also a valid Python expression with a... So I think the semicolon at the end doesn't change anything. I can just leave it, but whatever. Yeah, and that should be it. It actually should give me at... sorry. Oh, KrzaQ actually says I can do this even in a more funny way, which is Perl style if notation, which is probably the most hilarious thing I saw, but So Perl is like this. Perl is a really weird language, but it has a lot of fun stuff. And it's like writing in it is really, really cool. You cannot read it afterwards, but yeah. So it's the same thing. I'm going to stick with mine. Cool. Now I can do, let's do calc on ASDF, because why not? And let's see what this prints me. What will I get from this? I will get, I don't know, I won't get anything because I didn't do a return statement, did I? Yeah, I didn't. So, okay, let's do return. In our registers, I have to convert it to a string, and now I have to do encode hex. And this is how I do hex digest dump in Python. And I will print it. Perfect. Let's see if it works. So I'm going to run it. Did I have a console? I already had a console somewhere here, right? So Python ASDF py. And valid syntax because I forgot my colon. Okay. Must be in range. Where are you? No, seriously, where are you? Here. It's going to be like truncated or cut into bottom 8 bits anyway. Yeah. And I get this. This is my correct hash. I think correct. Well, it calculated hash at least for ASDF. And now what I need to do is I need to go here and see if I have this calc 64. Yeah, it's exported as well. So I need to, yeah, basically like, you know, run ASDF on it. And did I get the same hash? Probably yes, and then we can start brute forcing. And 9.8, well, no. So it's somewhat similar, right? I mean, 8.3, that's okay. B is okay. This is A. This is not... It differs on some bits. It doesn't differ on everything, but it differs on some bits. Like this part is, these two are okay. Or no, it's not these two, but yeah, whatever. Parts look okay and parts doesn't look okay, so which means that there is some problem and some issue somewhere here. Now, I actually obviously know what's the problem, and that was a minor trap I set for the CTF players, and the trap is in this. No, the hash is okay. I calculated in both cases the ASDF, like hash for ASDF. Now I'm going to tell you what's the problem. The problem is that if we go to this source code again, right, and we start looking into perm, we're going to find a funny thing, and the funny thing is called -0. -0. So what's -0 equal to? Well, -0 is equal obviously to 0, right? So if we do, even in JavaScript, if we do like something like this, -0 is less than 0, then, well, it will say false because -0 is obviously equal to 0, right? Now, the funny thing is in JavaScript, if you like assign -0 to a variable, it still sticks and says that, hey, this is still -0, right? It doesn't lose the sign. And in Python, if I would do the same, and let me actually do it. So let's go here, I'm going to run Python, I'm going to do the same. It loses the 0. Now, as you could see, I wasn't really... So if we go to math, right? And there's this signal thing, which is being used. Now, JavaScript doesn't have this. This is a custom function, and the custom function is defined actually here. Signum. And the signum function does this. Return 1 divided by a, where a being the tested value, lesser than 0. So this part is normal. Now the division is funny, especially the division for 0. So let's see how it works. If we go here, then so 1 divided by -0, this is obviously -infinity, and -infinity, if you test it against 0, is actually true. Now, if you do the same with +0, I'm going to, I guess, put this a little lower. If you do the same with +0, or actually like normal 0, right? 0 doesn't have a sign, or shouldn't have a sign, but it does have a sign here. It's false. So it's a way to test if -0 is actually really negative. Because if you do just math sign -0, it will return -0, which isn't helpful at all. That's neither a true nor a false. So, well, actually that's like, if you would cast it to Boolean, it would be obviously false. Now, Python doesn't have -0. Python casts it to, like, basically casts it to, you know, to a normal 0. Therefore, when we do the permutations, and we check the sign, Python returns for -0, it actually returns false, while JavaScript will return true. So, you don't see it. Yeah, JavaScript will return true. So this is what messes up our calculations. If I would do the same actually in JavaScript, then that would just work, right? Did you compare the hash from the terminal with the Vim? Well, I compared this. Oh, did I compare this one? Yeah, I'm sorry. It doesn't matter, it differs, but it's funny because like it still like has the same properties here, right? But it's still just a different hash, so it doesn't matter. Though you are correct, I did compare the incorrect hash. Now up to how to fix it. Well, we need to detect -0 actually here. How do we detect -0? In Python, we have to change the -0 into something else. So if I basically can do a regexp, like replace -0 with, now what do we replace -0 with? We can replace it with a string. Let's say -0, because why not? So everywhere, replace -0 with -0 string, global, enter. And I think it did the replacements. Now let's see, I'm going to just run it and it actually should, you know, complain because I'm doing something on the string. So inside the signum, I'm going to do a special test. If v is equal to -0, then actually return true. And this should fix our hash. So, yeah, I'm going to run it. No, I'm not going to run it because this is also still screwed up. How do I fix this in an easy way so I'm actually not... yeah, let's just do if I equals -0, then m.I equals 0. Yeah, this should fix it. Because I already have, yeah, that should be fine. Okay, and now it calculated something, and let me open the JavaScript console again. We can, what happened to my console? Please calculate my hash again. Now I will take care to actually to remember the history. Yeah, but I'm correct. Yeah, and now I think it's the correct hash. I mean, like, yeah, 183BA, 183BA. So now it works, and the end is F726. I'm just comparing like the end and the beginning of the hash. And there's some funny research, like somebody decided that this is what people do when they check, for example, the signature of a certificate or whatnot. So somebody like claimed that, hey, if you actually like brute force the signature, like, and get the collision on last 8 and first 8 bytes, which isn't so hard to do. Sorry, not bytes, but nibbles, then you can like trick people into thinking it's the same checksum, because nobody checks the middle, only people check the beginning and the end. But it doesn't matter here. Why bother implementing it in Python and JavaScript is already there? It's a good question. I would usually do it on a CTF anyway because I prefer Python. That's basically the only reason. And I know people did it during the CTF, so it's not like I'm just figuring like, oh, I want to show you this trick and nobody in the real world would ever fall for it. That's not the case. Like, people did lose some time on it. Not everyone. Some people just did as you proposed. I just did it in JavaScript. Cool. Now, so now the brute force, right? The brute force will be rather easy. I'm going to, this is the hash I want to achieve, right? And what I'm going to do is I'm going to check on, after brute forcing each bit, I'm going to check if the difference between like how many bits are equal between the hash, the correct hash, and the calculated hash did decrease, then I'm going to keep the new bit, and otherwise I'm not going to keep the new bit, basically. Yeah. How do I do it in a decent way? And by the decent way, I mean, how do I do it so I don't code too much? Well, whatever. I need to start with like final equals byte array. So that's 27 characters, right? 27 characters, 27 bytes. And this is all I care about. So yeah, and it's zeroed at the beginning, or maybe password. Password, yeah. Now for I in range 27, 8, and I start with, I guess I should just, I should, no. How did you disable it again? Whatever. Yeah, it's lagging a little, that's why I'm trying to disable it. So how do you do this? Well, you obviously flip a bit, so we need to select a bit, so that would be index byte equals I. Exactly the same math that was done earlier. Index bit equals I. Yeah. And then first I'm going to flip the bit, doing password index byte 1 shifted by this. Now I'm going to calculate this. Oh, I can actually just put password, right? I'm doing yeah, I'm changing it into byte array anyway, so I can just do this. So yeah, and then I'm going to, I don't know, flip it again maybe and do it like this. And then I'm going to have some function which actually calculates the difference between proper hash and this hash, and let's do it maybe diff equals I don't know. No, diff is going to be the name of the function, so d1 is equal to diff between h1 and hash, and d2 is going to be the difference between h2 and hash. Now, if d1 is lesser than d2, which means like less differences, then we are going to keep so now if d1, which was the flipped bit, right, this was the flipped bit, is smaller, then we are going to again flip the bit. Otherwise, we are going not to flip the bit, so yeah, let's do this. And after all of this, or actually like even during all of this, I'm going to do print str password, which is fine, yeah. And now I need to actually define that diff function, so... And what I get always this, right? As in a hex digest, so... I guess there should be some magical way to do it. Well, what I'm going to do is I'm going to just convert it into numbers, because that should help me a little. And now, until the numbers are equal to 0, I'm going to, or maybe, whatever, for I in range 512. Oh no, that's even... Yeah, I'm still trying to figure out a way how to do it without writing too much code. Yeah, I'm setting the bit, I'm not flipping the bit. This case, yeah, you're right. In another, here it can be, I know that the password at the beginning is just 0, so I can do this, then I need to do this to disable the bit, and then I can do this again to set it. Thank you, KrzaQ, you actually saved me some time. And now I'm going to, for I in range 512, I want to, I can just divide it at later, 0, if a, like the last bit, the least significant bit is equal to the least significant bit of the other one, then nothing, but if it's not equal, then actually increase d by 1, and then return d, which is the number of differences. I'm pretty sure you can write it in like a better way, but yeah, let's keep it like this. I know in Hacker's Delight there was a way to do it. I think, yeah, but yeah, whatever, doesn't matter. And now I'm going to just run it. D is the first letter. Seems to be working. Dragons is what, or dragon sector is actually the proper prefix to the flag. Are there any questions? Did I try to break Cicada, the newest Cicada? No, I never played with it. I've heard it's fun though. Can I assign -0 to a new int 32 array 1 and print it raw? What's the hex value of it? It's going to just be 0. So the story with -0 is actually that if you have a floating point, like you know, IEEE 754 compatible floating point, then actually you have the 1 bit for the sign, and you can, even if the number expresses 0, right, you can still switch on that bit which represents the sign, and then therefore you have -0. So it's related to floating points basically. And since number type in JavaScript is actually a double type from C, which means like a double precision floating point, that's why you have -0 in Java. In Python, I guess you can also have -0, but all sane languages quickly change the -0 into actually a 0, a normal 0. But yeah. So, and the standard actually says that -0 is equal to 0. It's quite surprising that JavaScript actually, like, preserves the minus there. So this is a flag, which is Humankind Empire of Abh. So, quick question to the chat. Does anyone know what is this reference to? Yeah, great work. So that's it. And actually, that took me 1 hour, which is longer than I expected. Okay, I already answered the question, why didn't I reuse the JavaScript code for the exploit? Which is, again, because usually I do stuff in Python, even if it's written in a different language. I try to copy it in Python because I can instrument it better. And that's actually also the case. I mean, I'm not the only person doing it. It's good it's probably not needed for this task, but sometimes it's really useful. Yeah, KrzaQ says that he didn't write it to Python, so it took this time. Yeah, I know, but I wanted to show this trick. And that was actually the only sticky stuff, how you call it. Cool, so yeah, that was how you solve this, and actually, yeah, I wanted to make today's live stream just 1 hour, so I guess I will not be able to show you the next tasks. If you'd like me to actually to show you the next, like the index forensics task, then, you know what, I'm going to like do a extend it by 5 minutes and just tell you what the task was about, maybe. So if we go here and we go to index, I didn't solve it in a proper way. So what you get in this case is like an exit file, but that's not the idea behind this task. Okay, you get an index file, right? Index.image. And if you do a file on it, then it says that it's an S Macintosh HFS extended version, blah blah blah. I don't know what's up. I know it's like a file system for macOS X, but I have no idea about macOS X. So what I did do is I actually put it into, and this is the short version of a challenge. It's 25 megabytes of files, so it's rather small. I did put it in Autopsy, so let me run Autopsy. Autopsy is like your basic UI for SleuthKit, I believe that's the name, which is like a forensics toolkit basically for file systems. Okay, so it's opening, but it's opening on my upper. Okay, so recent case. Okay, yeah. So this is Autopsy, and yeah, it doesn't actually. It finds one file, and the one file is file types by MIME, images, and PNG. There's actually like, yeah, this file, which is like a flag, and it's like totally red herring. There is nothing interesting in this file, kinda. This file is needed at the end of a challenge, basically, but you don't need to know that it was even that file. Then what I did, I went to the data sources, basically. Let me maybe do this. Yeah, sorry, my bad. Yeah, data sources, and there is something like unallocated data here, and I exported this unallocated data. And the unallocated data is basically, you know, data which is not really allocated to any files which are on the disk. It's just like, well, not really, maybe deleted files as well, but files that were never allocated, perhaps in this case. And I exported this thing, so you just like, I don't know, where's the export here? Where's the export? Tools export? Maybe I have to right click it. Yeah, extract file, sorry, not export file, my bad. Yeah, so I do this, then I just like export it somewhere. Yeah. And it's extracted, and it's in this directory. And the happy coincidence is that actually the unallocated data is 21 megabytes, while the whole image of index AMG is, well, 25 megabytes. So what I did is I basically took each block of unallocated, and one block being, by the way, 1 kilobyte, right? And I found it in index EMG, but it had to be aligned to 1 kilobyte, so it's actually a block. And I removed it from index EMG. So in the end, I got the difference of the sizes, and the difference is obviously like 4 megabytes. And having this file, I looked at it, and I actually the PNG flag, which I just showed, I also extracted it, so it left me like 3 megabytes, basically. And what I got was, just give me a second, I need to find it on my disk. Yeah. Okay. It's this file, and looking at this file, well, you can see is, I don't know, parts of executable, then I have absolutely no idea what, and then some names start to pop up, and actually if you do strings on it, you find out that it's a Go binary, like compiled to a Maho executable, which is like a standard OS X executable. And what you do is, what I did is I found where's the starting magic of Maho, so sorry, Maho executable magics, not magics, magic. Parsing Maho, Wikipedia usually has this somewhere. No, it doesn't have. Blah 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 blah. Where's the magic value? Here. Oh, this is like mh something something magic, so loader. And where this, perfect, it's here. So it's like feed something, feed fact, that's a weird magic. And now I look for it. You know, little endian, big endian, right? F-A-E-D-F-E. No, my bad. F-E and case sensitive. And it's not here for some reason. F-E-E-D F-A-C-D. Now then let's look for the second magic, which is, or maybe let's feed fuck. No. FE, then the second one, FE, ED, FA, CF. It's not here. No, come on, did I make a typo? It's quite weird that it's not finding it. But anyway, it's somewhere here, the magic is somewhere here, and what you get in the end is... what you have to notice is that half of the Maho file is at the... again, if I have this... crap, not this display. Yeah. If I have this this file, right, the one extracted, then you notice that the magic is somewhere here. I'm probably making a typo, that's what I'm... Or like looking at the wrong file. Yeah, I'm looking at the wrong file. Yeah, I'll show you the other file in a second. And this is the beginning of the binary, and then you have to notice that actually somewhere here near the beginning, but not at the beginning, there is the rest. So this is the first part, and this is actually the second part. So you have to carve this out, and then you have to carve, like, put it, I don't know, somewhere here, and then carve the other part to put it here, and you get a proper Maho binary. And if you... So, yeah, I was actually looking at the wrong file. Is this file? No. Yeah, I don't know. I don't have luck today. Somewhere here, though. Anyway, so you get the Maho file and you can put it into IDA. So let me show it how it looks. Show you how it looks in IDA. IDA is actually like really rather short. Well, it's not short, it's like 3 MB executable, but when you start looking through the main function, which is like main, so the name is main, so you are sure that this is the main and not the main, like main is not to be confused with main. You actually notice that it opens a file, and it does is like XORs the content of the file with a constant which is in this file, and the constant is this. No, not this. Where is the constant? Case sensitive is checked. Yeah, case sensitive was supposed to be checked. That's a good thing. Maybe this. No, that's the same thing. I'm actually really annoyed that normally when you press escape in IDA, it goes back, but if you like switch the views, escape doesn't go back to the previous view. This isn't it either. Somewhere here then. It's weird that it's not named. I usually name my constant, but I probably didn't save it. Oh, it's here. So you basically then take this, right? And you find the file on the file system which is needed to XOR it. And you do it by actually XORing the first 3, or sorry, maybe not 3, first 6 characters with D, R, G, and S, which is at the beginning of every flag. You can also add the curly bracket. And you XOR it with this, and then you look for whatever bytes you get. You look in the image for them, and you use that as the key. And it turns out that was actually the beginning of the flag file, I believe, is the key for this. And in the end, you get you get something like this, which, if you run the script, which I'm going to do now, yeah, you get the flag. So that was this forensics task, I guess, like shown in 10 minutes. Sorry about the speed, but it was worth 400 points. It wasn't too crazily difficult. You basically had to either have an idea how to solve it or know how to do forensics, like real forensics, on HFS Macintosh file system, which I don't know, that's why I actually used this method. If I would knew, it turned out that there were some like alternative data streams and some hard links pointing to weird stuff, and you could also like go that way, but you do need some knowledge about HFS to do it. Okay, so that would be it for today, actually. It seems I do not really have time to do the web challenge, so yeah. If there are any questions, how did I find where the second part of the file starts? So let me show you the file again. At the end of this is really the good file. I have too many files in that directory, in all honesty. So, yeah, I think it is this file. Doesn't look correct though. Yeah. So at the end of the Maho file, right? It's something like this. You can see basically there are a lot of zeros, but there are also columns of like 3 digits, basically 3 bytes. And it's the same here, like a pattern. This is a pattern basically. And this pattern I kinda realized that is related to the symbol section. That isn't really important what is related to actually. That important part here is that it is a pattern. So I went at the beginning of a file and started looking for the same pattern. Where is it, right? And there's like no pattern here, no pattern here. Oh no, sorry, I'm sorry. I did switch too fast. So again, the pattern. Yeah, the pattern is like this. Yeah, you can see it, I guess, here. The best way. And these are all zeros, like zeros here, and just 2 columns of 3 bytes. So this is the pattern, and yeah. And then I started looking from the beginning of the file, and there is nothing, blah blah blah, and suddenly the same pattern begins. And I decided that, hey, at the beginning of this pattern, this might be like the second part of the file, and it actually matches a block offset. Again, 1 block is like 1 kilobyte, I decided, right? And so this would match the beginning of 1 kilobyte. It would also match the beginning of 4 kilobyte, but actually, you know, I stick with 1 kilobyte block. So yeah, and that's how I found it. That was luck. I mean, I'm not saying it's like a good method. It was, I matched the patterns and I decided that's it, and it actually worked, and it actually correctly loaded into IDA, so with symbols and everything. So yeah, that's it. Okay, let me switch here. If there are any questions, I'm going to answer them, and if not, we can finish the stream. So do I plan to solve Pico 2017s like I did with Pico 2013? Probably yes, but if I know, if my information is correct, Pico CTF is still running, right? So I'm going to solve them after it finishes. Is there any other question? No, so I guess that's it for today. Thank you for staying with me, and like thanks to KrzaQ who helped me today with moderating, and see you next week. I guess next week is going to be either with a PJ exploitation or something else. I'm still finalizing plans for next week basically, so you see. And that's about it. So thank you very much for today, and see you next time. Bye bye. And I'm leaving you with some music as usual.